Alright, so let's do basically the same problem, 4 times the charm, with 7 white marbles and 4 blue ones. And instead of drawing with replacement, we're going to draw without replacement. And we're going to calculate the same probabilities, or the same events, rather. So, so if they're both white, right? You guys see that? The only way to get both white is to choose a white one and then choose a white one again, right?
Yeah.
So the first white one, there are 7 white ones in 11 marbles.
Yeah.
The second white one, there's only 6 white marbles left because you got one out, and there's 10 marbles left in the bag. So you have a total probability of what?
42 out of 111, or 110.
Perfect. 42 out of 110?
Yeah.
Okay. What if you're going to get a white marble, then a blue marble?
Those 2 whites that were taken out, are they back now?
White would be 7.
Oh, for this problem?
Yeah.
Yeah, you can assume that you're starting again with the full bag of marbles.
7 out of 11, 4 out of 10.
7 out of 11, and then
4 out of 10.
4 out of 10.
100 over 110.
So 28 per 110. And that would be this edge. Is all good with that?
Yeah.
Okay. How about 1 white and 1 blue? Is that the same thing?
No.
28 per 110?
So it would be 4/11, right?
So you could do 411 times 710.
Okay, so if you're going to do blue marble first, right?
Mm-hmm.
You have a 4/11ths chance of picking a blue marble,
Still,
7 out of 10.
still 56 over.
and then 7 out of 10 for the
28 out of
white marble. So that's 28 per 110.
And it's still 56 out of 110.
It's still 56, but remember, right? Remember the other way? It wasn't 56 per 110, it was with replacement, right?
Yeah,
It was 56 out of
21.
121.
Yeah, that's the only difference. So the top doesn't change.
Yeah, you guys see that? Which means that my probability of getting 1 white and 1 blue went up.
What? Actually, that makes sense.
Right, the difference between replacement and without replacement is that without replacement, your probability of ending up in that 1 and 1 state went up.
Makes sense.
Because of course, if the probability of being in the state where you're the same is lower, because the only way to get to be the same is to take one out and put it aside, right? Does that make sense?
Yeah.
Okay. So, little trees, helpful.
Can we do that on the test?
Yeah, so look, when we get to the probability questions on the exam, if I see a tree at all that has labels that are vaguely appropriate to the problem, I'm going to be like, cool, you tried a tree, check, 5 points.
Hey, let's go.
Right, so at least get the tree tried.
Yeah.
Try the tree.
Wait, so is the final going to have 15 questions? Oh, sorry.
The final's going to be, 15 questions, 10 points each.
All right.